This video is the first video of an experimental design, and we're going to cover a few definitions and also an example to help us try to understand those definitions. Okay, we begin with a couple of definitions. You'll see these on the left-hand side of your note page that I gave you. First is observational study. It's where we observe the outcomes without imposing any type of treatment on the subjects that we're studying. So just without any treatment, we just observe what's happening in an environment. And the difference, or the opposite of this, would be in the experiment. And an experiment is where we actively impose some kind of treatment in order to observe the response that happens in that environment. So in an experiment, you do have a treatment. In an observational study, you do not impose a treatment. And the next thing, we're going to go through an example of an experiment, an observational study that leads to an experiment, to try to kind of get in our brains what this means. And it might be a good idea for you to write some of your own notes down somewhere. There's not space on the paper that I gave you, but maybe on an extra sheet of paper if there's something that stands out to you to write down to help you remember. So let's say that a company has developed a new kind of rabbit food called Hippity Hop, and they claim that this food will make the rabbit's fur soft and shiny. It will increase the energy that the rabbit has, and it contains 100% of the vitamins and oils that this rabbit needs. And so these are the claims that this company is making about this food. And so let's ask ourselves a few questions about these claims that they're making. Can this company just make these claims without any supporting evidence or studies or experiments? And the answer is no, they cannot. That would be false advertisement. In order for this company to make those kinds of claims, they would have to do an experiment to support their statements that shows that what they've said is actually indeed true. And they would have to do this experiment concerning these rabbits. So what should they test, or who should they test? Well, if they're testing rabbit food, they would have to test it on rabbits. You wouldn't want to test the effects of rabbit food on a horse or something like that. It's got to be done on the subject that it matters for. And what do you test? Well, you've obviously got to test the type of food, because that's what you are claiming is making the difference, or what this company is claiming is making the difference in these rabbits. And these kinds of things we'll learn some terms for, who I'm testing and what I'm testing. Those have special names when we're doing experiments by definition. We'll talk about in a moment. And so continuing with the definitions on your paper, the first one here, number 3, is the experimental unit. That's the single individual. This can be a person, an animal, a plant, etc., to which the different treatments are assigned. And so in this case, in our case, our experimental units would be the rabbits, because that's what we are doing the testing on. Next, we have the factor, and this is the explanatory variable. Remember, explanatory variable is your cause in your relationship. We can kind of think of it like that. And we can also think of it, remember, that's the X, or the independent variable. And so in this case, our factor would be the type of food that the rabbits are getting. And the next one is the level. And the level is a specific value for the factor. So the level is tied to what your factor is. And in this case, we might test one type of food, we might test 2, but our food may not have different kind of levels. You don't always have to have levels in an experiment. The next definition is the response variable. That's the Y, or the dependent variable, and that's what you measure. And so in this case, our response would be how these rabbits grew. Are they bigger? Or how their fur was changed, because that was one of the claims. Is it shinier or not? things like that would be our response. And number 7, the treatment is a specific experimental condition applied to the units. Remember, experimental units. So the treatment is a specific condition applied to rabbits in this case. Okay, so we've kind of talked about each of these already with our definitions, but just to reiterate, if we're going to test this new rabbit food, what would our experimental units be? And we determined that our experimental units would be the rabbits. What would the factor be? We determined that would be the type of food. And our response variable would be how well they grew. Some kind of measurement is important for response variable. We have to be able to measure that. Okay, so now we're going to conduct an experiment to determine whether or not the claims of this company are truthful or not. And in this study, we decided that we'll just use my Lucky rabbit. It's my pet. His name is Lucky. And as you can see, Lucky is pretty fat already and doesn't look too bad. And I'm going to use only Lucky and feed him only this hippity hop food. So just the new food. And so would you be convinced that hippity hop is better just based on that and looking at Lucky in his current state? I'd have to say no, because since Lucky's coat is shinier and has more energy, so hippity hop must be better. And I would have to say no, this was not a good experiment, because the only rabbit being tested was Lucky, and the only food being tested was hippity hop. So it's not a good experiment. And so to avoid situations like the one we just discussed, we want to have these things called control groups and placebos in effect. A control group is a group that's used to compare the factor against, and it can be a placebo or it can be the old or current item. A placebo, you may have heard of before, is a treatment that's really not a treatment at all, and that can have no physical effect whatsoever. So you may oftentimes hear this in the medical field where people have been involved in a study on a certain kind of drug for prescriptions and to cure ailments, and one group has been given this new drug and the other group has been given a placebo, which just looks like the drug that actually causes a physical effect, but it has no effect whatsoever. And many times it has been found in studies that the placebo has the same effect as the drug, because the people's attitudes have changed about their position. Sometimes that helps. Alright, so now our experiment's going to change, and I'm going to introduce a control group. And in this particular instance, I have my rabbit, Lucky, over here to the left, and then I'll use my friend's rabbit, Flash. And Lucky's going to get the hippity hop food, the new one, and Flash is going to get the old rabbit food. Now looking at these two rabbits already, I noticed that my rabbit is already larger than my friend's. So what can we conclude? Is this a good experiment or not? Because it appears that, oh wow, Lucky's bigger and shinier, so hippity hop must be better. But actually this is not a good experiment, because Lucky is already bigger to start with than the other rabbit. Plus, you're giving the other rabbit the old food, and you're giving Lucky the new food, and not both. So I'm going to change this experiment yet again. I'm going to introduce several rabbits into the experiment, not just Lucky and not just Flash, and so I have rabbits of various sizes to try this stuff on. And I decide that the first 5 rabbits that I catch will get the hippity hop food, and the remaining 5 will get the old food. And so what rabbits do you think are going to be caught first? Well, of course, the bigger, slower rabbits will be caught first, and so they'll get the hippity hop food, and in the end they'll be bigger, as they were in the beginning. And it appears that the hippity hop rabbits have scored higher, so it's a better food because these rabbits are going to be bigger. However, is that a good experiment? And the answer is no, because all the rabbits we caught were the larger ones, and so the experimental units, which are the rabbits, were not assigned well to our experiment. And so this would not be a good experiment either. So finally I decided to change the experiment again. And I randomly assigned the numbers 1 to 10 to each of these rabbits in the group. I then place these numbers in a hat. They're all on the same size piece of paper, and there's one number for each rabbit assigned. So an equal opportunity. And the first five numbers pulled from the hat are going to be the rabbits that get the hippity hop food, and the remaining 5 will get the old food. So the numbers are drawn from the hat, and this is the result. So I have various rabbits assigned. I have some smaller ones over here for hippity hop, as well as larger ones, and I have some medium-sized larger ones here, not any real tiny ones, but that's okay. I still have a good disbursement of rabbits assigned. And upon evaluation, I evaluated the rabbits and found that the rabbits eating hippity hop were better than the old food because they had better measurements in the categories that we decided to measure. And this was a good experiment because the rabbits were randomly assigned, everybody had an equal opportunity. I had one group with the new food compared to the one group with the old food to see which was better. And so in the end it says that hippity hop rabbit food makes fur soft and shiny and increases energy for all types of rabbits. And could this company then make that claim? And I think the answer is yes. They might want to say through experimentation and through evaluation we have found that our food does in fact increase these things for all types of rabbits. We're going to finish up with a couple more definitions. First of all, it's blinding, and that's a method used so that units do not know which treatment they are getting, because sometimes it does affect their answers if they know. When we're talking about the placebo, sometimes that does affect. This is similar to it, but if you've seen the Febreze commercials where they blindfold people and put them in different environments to determine whether or not where they are, that's an example. Or taste test. They have a blind taste test sometimes. TV shows sometimes with competitions, they don't know who cooked what, and they have a blind, that's a form of a blind taste test. Double blind is where neither the units, that's who you're testing on, nor the evaluator, that would be the person doing the experiment, know which treatment a subject has received. And so sometimes the double blind test is done as well.